In this video, we are going to create a machine learning model to predict the stock price based upon its historical prices. Before going to the main details of the video, let's look into the final output of the project, how it looks. Here, text box, and press enter, and our model is started running it, our web application. Yes, now this is the Tesla stock price from 2012, 3rd of January to and last 10 years of data. Okay, so 2022 December 30th. Okay, and here it is price versus moving average of 50. So what is the closing price versus the moving average 50? So these moving averages will be used for the strategy purposes. So to make this web application complete, so we just added this moving average 50, and here also moving average 50 versus moving average 100 with the price, and again price versus moving average 100 versus moving average 200, and this is what the final original price versus predicted price. So if you see here, I think around for 500 days, I think our stock almost touching for 20 times, at least 10 to 20 times, I think it is been predicted the actual values. Okay, so this is the complete web application. Let's dive into the video. First things first, let's decode this project. Here we are going to build a neural network which is capable to handle the time series data, because the stock market price is relevant to the time of the data. So first we will need the data. So what kind of the data we would need? We would need the stock market data for with respect to this time. So once we have the data, we have to do the pre-processing of the data. Pre-processing of the data means we have to make sure that our data is clean and it should have the proper values and it should not contain any duplicate records. So once we do all the cleanup process as part of the pre-processing data, our data is ready to feed to the model. So now the next part is we need to create a model. So what kind of model which we are going to create here is, as I said earlier, we are going to create a neural network which is LSTM. Long short-term memory is a type of recurrent neural network that is specifically designed to handle this kind of sequential data such as time series, speech and text. LSTM networks are capable of learning long-term dependence in sequential data, which makes them well suited for the tasks such as language translation, speech recognition, and time series forecasting. So once we create this LSTM model, we have to train that model with the data. So once we do the training of the model, then we will be evaluating our model, how it is working. So once we get the satisfactory results in the testing of the model stage, then we will be saving that model for further, and then we will be deploying it as a final web application. Tools required to do this project. The first one is TensorFlow, which is a Python library which used to create these neural networks. And second one is Finance, which is another Python library which will get the stock data from the Yahoo Finance website. Matplotlib Python library will be used to draw the charts with the stock market data. Here we are going to draw a couple of charts. And next one is NumPy and Pandas, which are basic libraries to work with the data for the machine learning models. And next one is Streamlit. So once we do all this kind of model creation and everything, so we need to deploy it as a web application, right? So Streamlit does it for us. Let's dive into the coding. Let me open my Jupyter Lab. So my Jupyter Lab is ready. Now let's open it. Let's import the necessary libraries. One is NumPy as np, import Pandas as pd, and import Matplotlib to draw the charts. And we would need another one which is Finance. Let's import the libraries. Libraries are there. So if you don't have these libraries, just open your command prompt and type pip install with the library names. So you can be able to install these Python libraries. I already have these Python libraries in my system, so I'm not going to install them again. For this model creation, we would need the stock market data, right? So let's get the stock market data. Start date is equals to, I would like to get the last 10 years of the data. Okay, so that if the data is more, then our model can be trained very well and it will predict the proper results. And is equals to last 2 years data, right? 12, 31. And stock symbol, every stock will have a symbol. So let me open Yahoo Finance here, finance.yahoo.com. Let's take off Google, okay, which is trending. The symbol for this Google is GOOG. Okay, stock symbol is equals to GOOG. Okay, let's get this stock data. Data is equals to YF dot download of stock, comma, start date and end date. So it will get us the relevant data. So data has been downloaded now. Let's see how this data looks. Data. Okay. So here is the data. So here is the data. So on so this date. So 2012. So 3rd of January. So this is the opening price of the product. Let's understand the data. So here the first column is date, which is an index column. And next columns are open, high, low, close, adjacent, close, and value. Let's understand the stock market terminology. So stock market is a market where the seller sells their shares and buyers buy their shares. Okay, and the price of this stock will be fluctuating for each and every second based upon the demand and supply. We are not going into that second level data, so we'll be taking the high level data. Okay, so first one is open here, right? So that is the morning price. When the stock market open, this is the price of the Google stock on 3rd of January of 2022. It is around $16.2. Okay, and what is the high says that what is the maximum price of that particular stock on that particular day. Okay, it went around 16.64. And then what is the low? So what is the minimum value? What is the lowest value of the stock price on that particular day is 16.24. And finally, which is relevant to us, which is closed price. So closed price is the when the stock market is before closing that, right? So what is the final price is that on that particular day is $16.57. And adjacent close, we don't need that. And the volume here is the number of shares has been changed from sellers to buyers. So now we understand the stock market data, right? Now let's do one thing. So we have to reset this index. So here the index is date. So let's reset this index date to normal date. Okay, date dot reset underscore index in place is equals to true. So instead of date, we'll be having zeros and ones as an index. Yeah. So that's what it does. So it has created a new index and date is there, open, high, low, close, adjacent, close, and value. Now, so this is the stock market data, and once we have the stock market data, and the stock market data will be creating based upon the certain strategies, they will be estimating the stock price, but we are not doing that. So the one of the general terminology or general strategy which will be they'll be using is moving averages. So the moving averages in the sense, so based upon the last 10 days price of the stock, then they will be estimating the 11th day. So that is what the moving average. So let's create a moving average chart over here to demonstrate it. Okay, let's take the 100 days moving average. So moving average of 100 days is equals to data dot close price. That's what we're interested. Rolling data for the last 100 days, which is mean. Okay, now we have the last 100 days data. So let's draw a graph. Plot the figure. Fig size is equals to let's give it as 8,6. Next, plot of moving average 100 days in red color, and same way plot data dot closing price of the project, closing price of the stock, and close green. So here is the price. So here is the closing price, which is in red color. And if you see the red color, this is a moving average. So there is a general strategy. If it is above some moving average, the price will go up, and if it is less than that, then the price will go down. It is a just general strategy, so it may be correct, sometimes it may go wrong. Okay, stock market is like just a gambling, at least for me. Now we have the moving average for the 100 days. Now let's calculate it for the 200 days, and then we'll see. Moving average of 200 days is equals to data dot close dot rolling of 200 days with the mean. Okay, now we have the moving average for the last 200 days. Now let's draw the graph. Plot dot figure fixed size is equals to 8,6, and plot of moving average 100 days in red color. Okay, and plot of moving average 200 days, next blue, and plot of data dot close green, plot dot show. See here, so this green line is the actual closing price, and this red line is for the moving average for the 100 days, and blue line is for the moving average with the 200 days. Now we have the data, and we have drawn the some charts as well. So now let's see what we are going to do with the data. So we have the data with the closing price, right? So let's concentrate on the closing price. So we don't need data open, high and low, so we don't need all those stuff. So data is already there, so we don't need to worry. So each and every day data will be there. So this Yahoo Finance, this Y Finance Python library is there, right? I have just checked the data, so the data is already there. If you want, we can just check it out. If there are any null values, it can get rid of. So what I can do is data dot drop in. If there are any null values or missing values, then that particular data will be deleted. So okay, so it will be gone. Now we are done with the data cleanup activities. Now what we are going to do is, let's distribute this data into 90 days, 80% of the training data and 20% of the test data. Okay, so let's split it up. Data score train is equals to data dot close of from 0 3 cut to length of the data into 0.80. Okay, let's convert it into integer. And data underscore test is equals to data of dot close of. Here we'll be having 80% of the data as a starting point. So last 80% of the days data will be used for the training our model, and remaining 20% will be used to the test that model. Okay, then length of data. Okay, closing parentheses for the second line is missing. Int is missing here. Okay, key tuple of the type tuple not found on click syntax. Let's create a data frame. Data frame pd dot data frame. Here instead of, okay, now we got rid of it. So total we have the 2761 rows, right? So out of which 80% will be the training data set, and remaining 20% will be the test data set. So let's draw the shape. Data underscore train dot shape, So 2200 rows will be part of the training data set, and data underscore train dot shape of 0. It's not train data. Let's check for the test data. So train data set is 2208. Same way will be the 2200, right? So remaining 600 will be the part of the test data set. Data underscore train dot test dot shape of 0. Sorry, my bad, I have made some mistake here. So 0.80, right? Okay, let's change it to 0. So 553. So when we do the summation of these two things, we'll be getting 2761. Okay, so now we have splitted the data into training data set and testing data set. Here we have the training data set and test data set, right? Now let's do the scaling here. So what we will do the scaling here is, instead of the actual stock price, we'll fit the actual stock price into the 0 and 1 numbers. Okay, we can do this slicing with the help of the one of the algorithm from sklearn dot preprocessing import min max scalar. Scalar is equals to min max scalar feature range is equals to 0 comma 1. Okay, let's scale the actual data to 0, in between 0 and 1. Okay, scale data underscore training data underscore scale is equals to, let's do the training data set first. Let's data train scale scalar dot fit underscore transform of data underscore train. So we are scaling the training data set between 0 and 1. So once we do that, then we need to do the array slicing here. So array slicing concept will work here like, so let's take the first n days to calculate the n plus 1th day stock price. Suppose let's take an example of stock price for the first 10 days. Okay, 10, 11, 12, 15, 16, 17, 18, 19, 20, then 9 came to 17, 1 2 3 4 5 6 7 8 9 10. So this is the 10 days stock price. So to predict the 11th day stock price, so it will take the consideration of the first 10 days data. Okay, and then for the next day, 12th day, it will take the consideration of the data from second day to 11th day. So this is how the stock market estimation will be predicted. Okay, this is how the stock market prediction will be happening with the neural network model. So now do the array slicing here with the input data set, which is training data set here. Okay, here I'm taking the first 100 days data to calculate the data of 101th data. Okay, because the higher the data, so higher the accurate results are. For range I in, for I in range of 100 comma data underscore train underscore scale dot shape of 0. Let's take two arrays here before going there. X is equals to one array, y is equals to another array, to two arrays, and coming to end, x dot append of data underscore train underscore scale of I minus 100, then I v dot append data underscore train underscore scale I comma 0. So this is what the array slicing happens. So I'm taking the first 100 days data to calculate the next 101 data. So same way I'm making that our input data set as well to be in sync with that our logic. Okay, based upon this training data set we'll train our model. So now let's create a model. Model is equals to let's import the necessary libraries first. Import keras.layers from keras.layers. Import dense dropout and LSTM model from keras.model. Import sequential. Okay, so it is importing those layers. Don't worry, I'll explain it in the end. Let's create the model. Model is equals to sequential. Okay, don't worry guys, I'll explain it each and every line which I'm going to code here. Okay, model dot add of LSTM. Okay, units equals to 50 and activation is equals to relu and return sequences equals to true. Return sequence is equals to true. Input shape is equals to x, right? So x dot shape of 1 comma 1. Okay, so we have created a model with the layer of LSTM. Now let's add the dropout layer 0.2. Okay, now model dot add of LSTM units equals to 60 here and activation is equals to relu and return underscore sequences is equals to true. Now I'm not taking input shape here. Model dot dropout 0.3 model dot add model dot add of LSTM of units equals to 80. Activation is equals to relu return underscore sequences equals to true. Model dot add of dropout of 0.4 model dot add LSTM of units equals to 120. Activation equals to relu. So we don't need return sequences, we're ending it here. Next, model dot add of dropout 0.5 final. Next, model dot then model dot add of dense of units equals to 1 because we are only predicting only one value. Let's press enter. X dot shape. Okay, let me do one thing here. So we need to convert them into arrays here. Let's add one more thing here. x comma y is equals to np dot array of x comma np dot array of y. Okay, so our model is ready. Okay, now let's compile our model dot compile. Optimizer is equals to Adam and loss is equals to mean squared error. Compile the model as well. Now let's fit our model dot fit x comma y comma epoch is equals to 50 and batch size is equals to 32 and verbose I'll give as 1. Okay, let's enter. So our model is getting fitted here. So let's understand the code which I have written now so far. Okay, so first we are taking the necessary libraries numpy, pandas, matplotlib, pyplot and yfinance as well. First I have imported the necessary libraries here. So once I have imported the necessary libraries, we have taken the data, okay, stock market data for the last 10 years. So once we got that, so I have reset the index instead of the date. Now we'll be having the zeros to ones. So this is the data. So once we have the data, so I have calculated the moving average for the 100 days to draw the charts. And next way we have created the another chart with the moving average of 200 days here. So this is done. Then we have removed if there are any null or missing values are there. So we have removed that from the data set. Now we have the training data set and test data set. So 80% of the data set will be the trained data set and remaining 20% of the data will be the test data set. Okay, so 2208 rows will come into the training data set and 553 rows of data will become the test data set. Now here we are taking the min-max scalar which will be used to fit our data in between the zeros and ones. Okay, and we have applied that scalar to our training data set which we are using it now. So now here we are taking the array slicing here is happening. So I'm taking the first 100 days to consideration to calculate the 101 day stock market price. So that is how that array slicing is happening here. And I'm converting these two input data sets to arrays, numpy arrays. Now I'm importing here the layers, Keras layers. So Keras layers will work like it is like a independent layer. Okay, one layer, all these layers will be placed in a sequential manner. So output of one layer will become the input of the another layer. Okay, here we are creating the layers for the dense, dropout and LSTM. Okay, and sequential is the one which I have explained earlier, which is a neural network which will be used to predict the data based upon the time series. Okay, I'm creating the model here with the sequential. Now what I'm doing here is I'm adding the LSTM. What is meant by units is equals to 50 here. So I'm creating the neurons for each and every model. Okay, each and every layer. Now we are creating the 1, 2, 3, 4 LSTM layers for the sequential. So each layer will be having the different number of neurons. So first layer will be having the 50 neurons and second will be having 60 and third one will be having 80 and fourth one will be having the 120 layers. Okay, now activation is ReLU. ReLU is one kind of the neural network parameter which will be passed to calculate this RNN neural networks. Okay, and return sequences is equals to true in the sense what it says is it will be the output of one layer will become the input of the another one, right? So that is what we are mentioning here. Return sequences is equals to true here. So if you observe here carefully, I have mentioned only for the first three layers because the fourth layer is the final layer, right? So we are not adding that return sequences is equals to true because there is no other fifth layer to pass it upon. Now here is the shape. So what is the input data shape? So based upon that I have passed this input data shape. Now what exactly this dropout does is dropout makes what exactly happens it is if we go with the completely only on the training data set, so our model will be fitted too tightly. So it will completely rely upon our training data set. So it will may not give the accurate results in the practical world. So that's the reason we are giving this loss of 0.2. So 20% of the data every time will be, instead of the actual values, it will feed the mean values. So that's the what the dropout says. Here I'm mentioning 0.2, that means 20%. 0.3 means 30%, 0.4 means 40%, 0.5 means 50%. Now that is what this then dropout makes, that the model is not too overfitted. Okay. And finally dense. So dense units equals to 1, because we are going to predict the only one value, which is the closing price of the product, closing price of the stock, right? So that's the reason I have mentioned units equals to 1 here. Now we are using the optimizer is Adam, and whenever there is a loss, we are going with the mean squared error. So that is what the compiling is happening. Then I'm just splitting this model with the x comma y. Epochs is equals to 50, in the sense 50 times our training data will be pushed from starting to the ending every time. Okay, and every time whenever it is taking the data, so it will take the 32 batches, 32 rows of the data will be taken. Okay, and verbose is equals to 1, means that says the printing of this data. So that's it. Okay, that is what our code which we have written. So we have created the model with 1 2 3 4 layers, and we have made sure that our model is not overfitting. Then we are only estimating only one value, which is where the value is units equals to 1, which is nothing but a closing price. And we are using optimizer is equals to Adam, and loss is equals to mean square error. So don't worry about these things, guys. So I'm making another video in my channel with complete this Keras layers and everything. Okay, for now, for this model, I think this is the necessary information for you guys to get started. Okay, and let's see that how many epochs get completed. So 32 is running, so let's wait for some other time. Okay guys, I think our model has been completed its training. Let's see the summary. I just to show you guys this summary, I'm just showing it here now. So if you see here, this is the layers, this is the model sequential 2, and here is the layers. So layer 1, layer 2, and layer 3, and layer 4, which were created with LSTM, and these are the dropouts. Okay, and 4 dropouts, and one is the one dense layer. Okay, so this is what it is. Now we have completed our model summary. So now what I'm going to show you guys is, let's test our model. Okay, so to do the testing of our model again, so the slicing operation thing will come here, right? So based upon the past 100 days data, we'll be calculating the 1/1th data. So we need the last 100 days from the training data set to be added to the training scale. We need the last 100 days of the data from the train data to test data, so that the training test data sequences or test data we need the so here again we'll be applying this array slicing operation here. So for the last 100 days, here also the array slicing thing comes up, right? So even for the testing as well. So to get started with the first day, so we need the last 100 days data, right? So let's take the last 100 days data from the training data set, and let's get added to the test data set, so that for the first row in the test data set will become the 1/1th row, so that our model can predict the values and then we can evaluate. Okay, so what I'm going to do now is, let's take the past 100 days from the training data set, data dot data underscore train dot close. Anyways, only close is there, right? So tail of 100 days data. So I have taken the last 100 days data from the training data set, and let's get added to the test data set. Data underscore test is equals to pd dot concatenation of past 100 days data. Okay, now again I'm adding this data underscore test data, ignore index equals to true. Okay, so now let's see that our test data set. So this is our test data set. Earlier it was 553, now it is 653. Okay, because we have added the last 100 days data from the train data set. Now let's scale this data to between 0 and 1. Data underscore test underscore scale is equals to scale dot fit underscore transform of data underscore test. Okay, it's done. Again, we need to take the array slicing as well, right? So we need to take these two arrays. Let me copy the data from here. Let's change it to test instead of try. This is done. Now predict the values. Y underscore predict is equals to model dot predict the values for the x, right? So prediction is happening. Okay, I think I made some mistake. The mistake is we have to convert these two to again arrays, right? X comma y is equals to x np dot array of x and np dot array of y. Okay, predicted that. Execute this one. Yes, our model has predicted in 1 second 42 milliseconds. Okay, that's cool. And y score predict is printing these values. Okay, if you see here, our values are fitted in between 0 and 1, right? So let's convert it back to them to the actual price. Okay, for that one, what we have to do is there is an option scale is equals to scalar dot scale underscore scalar, right? Okay, scalar. So what it does is the value which it was being divided, right? So to fit into the 0 and 1, so the min max scalar will identify one x value. So based upon that x value, we'll be dividing all the prices of the stock, so that it will make sure that all the minimum and maximum starting price to the ending price will be fit between the 0 and 1 for all the rows, right? So that is the value which we are trying to find out here. So let's do 1 divided by scalar dot scalar. So 82 is the 82.7 is the value which had been divided by for the input data set, so that it has been converted between 0 and 1. So we'll be using same multiplication with the same thing, so that we'll get the exact values here. Okay, y underscore product is equals to y underscore predict into let's assign it a one variable scale. Okay, created a scale, next scale here. Okay, same values y as equals to y into scale. So now we have the predicted values and the actual values. Let's try a graph to see the how accurately our model had been predicted. Okay, for that one, let me draw a chart. Plot dot figure of fixed size is equals to, let's try and come a bigger one, and plot dot plot of y underscore predict in red color, and label is equals to predicted price. Okay, now plot dot plot of y and green color, and label is equals to predicted price. This is original price. Okay, now plot dot x label will become time, and plot of y label will become price, and plot dot present plot dot show. So this is a chart. So the red one is the one which we have predicted values, and green one is the one which is the original price. Say out of 600 days, I think it has 1 2 3 4 5 6 7 8 9 10 11, around like 20 25 times it had predicted very accurately, and sometimes it is a little bit less when compared to the original price, and sometimes a little bit higher than the original price. Okay, so maybe we can tweak our data a little bit, and then we can take consideration of open, high, low, and close as well for a bigger project. For this one, I think it will be fine. Okay, and so now we have this data. Let's take it into the another level. So create a web application with this data. Okay, whenever a user enters a stock symbol, then it has to do all this process again. Okay, so before that, let's save our model dot save of stock predictions model dot keras. Okay, okay, our model will be saved here. Now let's jump into the Visual Studio, then we'll create a web application over there. Okay, now we have here, let's get a file app.py. Now let's import the necessary libraries again. Okay, import numpy as np and import pandas as pd and import yfinance as yf to get from keras dot models import load model. Let's take the model here. Let me copy it from here, copy path. Okay, now super, we have loaded our model and we need streamlit, right? For web application, import streamlit as st. Okay, now we have numpy, pandas, yfinance to get the stock market data, keras.models to load the model, and now we have the streamlit. Okay, now let's have the header, st.header, and web page name will be stock market predictor. Let's name it as stock market predictor. Okay, and st dot, we need the text input, right? Stock symbol, enter stock symbol. By default, let's have it as a Google ZOOZ. Okay, and we making into one variable this input data set. Now let's go with the start data is equals to starting date will be 2012 January 1st and end date will be 2022 December 31. Okay, so we have start date and end dates. Now let's get the download the data, yf dot download stock comma start comma end. Okay, now we have to split the data, right? Data underscore train is equals to data dot close of 0 to int. I think we can get copied from here, right? Slicing of the data can get copy here. Okay, we have the test data and training data here, and we need a scalar, right? For that, import scalar under preprocessing from min max scalar, right? And scalar is equals to min max scalar feature range is equals to 0, 1. Okay, now we have a scalar as well, and okay, we have the stock market data, and we have split it between the test data and training data, and then let's fit our data into here. Okay, data and scope. So we need the last 100 days of data here, right? So let's take past 100 days data from the training data set. Okay, data dot data underscore train dot tail of last 100 days data. and data underscore test data will become pd dot concat past 100 days, then training data set, right? Training data set there, and ignore index is equals to true. So once we have the test data set is ready now, so let's scale the test data set. Scalar is equals to scalar dot fit transform of data underscore test. So our data is set now, and let's do the array slicing here. Copy the array slicing data again from there to here. This will does the data train scale. I'll do that. Okay, have the data now, so it will be calculated. Let's convert x comma y into numpy arrays. Np dot array of x, np dot array of y. Okay, now we have all these things. So before coming here, so we have the data here, header, and let's see how the data is coming now. st dot subheader data or raw data. Let's call it as a raw data or stock data. Okay, let's call it stock data, and st dot write off what we are going to do data. So let's see first. Okay, and terminal. Okay, streamlit run app.py. Okay, we have opened this web application which is running now. Okay, so for this Google, I think it is taking the data. Okay, so we have the data. Raw data is ready. Stock market predictor, enter stock symbol, Google, stock data is ready. So let's draw the graphs with the moving average of 50, 100 and 200. Okay, let's do that. And anyways, let's finish this coding here. Okay, we have added the numpy arrays, right? Okay, we have added the numpy arrays. Now what I'm going to do here is predict these values, right? Predict values is equals to model dot predict of x. Okay, and once it is predicted, we have need a scale, right? Scale is equals to 1 divided by scalar dot scale underscore, and predict is equals to predict into scale. So we fit the data between 0 and 1 here. Now again we are changing it back to the normal price values. Okay, and y is equals to y into scale. Okay, this is done, and here we need to have draw the graph over here, right? Let's draw the charts here. So first we have data here. Now let me take this data, copy it here, and before here let me do one thing. Subheader moving average 50. Okay, what I'm going to do is calculate the moving average for the 50 days. 50 days is equals to data dot close dot rolling of 50 days with the mean values. Okay, and let's draw the figure over here. Fig 1 is equals to plot dot have imported. Yes, no, we haven't imported matplotlib, so let's import it. matplot library dot pyplot as plot. You can import the libraries even in the middle as well, but it is not advisable. I think it is not readable code, so I always prefer to write the libraries in the starting itself. Okay, plot dot figure, and fixed size will be 10 commit. Okay, and plot moving average 50 days with a red color, and plot of um, data dot closing price with green color. Okay, and yeah, plot dot show, and st dot plot of fig1. Okay, I'm saving it. Coming to here, source file has been changed. Yes, rerun. Okay, streamlit has no attribute plot. Okay, pyplot. Saving it. Coming back here, rerun. Yes, so this is the price with the moving averages of 50. Okay, it has done true features. Yeah, so this is the predicted versus actual values, right? Now let's do one more thing here. Okay, let's draw for the 100 days moving average and 200 days moving average as well. Okay, let me copy this entire thing. Price versus moving average. Let me decrease the little bit of size here. 8,6. Okay, and yeah, copying it, pasting it here again. Price versus MA15 versus MA100. Which I'm making it as figure 2. Let me pass this figure 2 here, and let's change it to 100 days. Here also I'm changing it to 100 days. Okay, I'm saving this file. Coming back here again, here we can change in the settings, run on save. Every time the source file gets changes, it will automatically get refreshed or re-executed. Okay, so price versus moving average of 50, price versus moving average 50 versus moving average 100. Okay, now let's calculate it for the 200 days. 2. Now go back to figure 3. Let me change it to 200 days. Okay, and 200 days here. Let me change it to 100 days, and this one to 200 days. Okay, 100 days and 200 days. Okay, it will be fig3, and here also fig3, right? Now let's check it out. Saving it, and it's running already. So I had saved it already, so it's running. So stock data, and price versus MA50, price versus MA moving average 50 versus moving average 100, and I think both the colors are coming in red color. I guess here also it is coming in red color. Let me change that, or B. Okay, I'm just saving it. It's already getting refreshed. Now we see that, okay, this is moving average 50 versus price, moving average 50 versus moving average 100, moving average 100 versus moving average 200. Now this is the first graph. I think it is getting printed here, but in place of this one, what we have to do is original versus predicted prices, right? So let me copy something similar here and come back to here, and I'm just removing this line, changing this line to okay. Okay, original price versus predicted price. Okay, figure number 4, and let's have it as 8,6 only. Instead of moving average 100, here I'm going to have predict values, right? Predict or, and what is the next one? Predict or, and let's add the label here, original price, and here y, it's green, yes I want to be green, and the label is equals to predicted price. Okay, just removing this one. Let's add the x label and y label. X label is equals to time and plot dot y label of price. Okay, changing it to figure 4, finally changing it here, and it's running again here. Okay, so symbol GOG Google, stock data it is, price versus moving average of 50 days, price versus moving average of 50 days versus 100 days, moving average 100 days versus 200 days, and finally original price versus predicted price. Okay, this is what it is showing. And why this line is coming, let's check it out if we can. Here is the mistake I have done. Instead of train I have used, instead of test I have used train dataset over here, so I have just changed it. Now it should get refreshed. Now it is giving the actual values, original price versus predicted price. Original price versus predicted price. So this is the original price and this is the predicted price. So this is the stock market predictor final web application. So you can go to the Yahoo Finance and search for a stock Tesla. Let's check for the Tesla, and Tesla symbol is TSLA. Just copy this symbol from here and paste it in this here text box and press enter, and our model is started running it, our web application. Yes, now this is the Tesla stock price from 2012 3rd of January to and last 10 years of data. Okay, so 2022 December 30th. Okay, and here it is price versus moving average of 50. So what is the closing price versus the moving average 50? So these moving averages will be used for the strategy purposes. So to make this web application complete, so we just added this moving average 50, and here also moving average 50 versus moving average 100 with the price, and again price versus moving average 100 versus moving average 200, and this is what the final original price versus predicted price. So if you see here, I think around for 500 days, I think our stock almost touching for 20 times, at least 10 to 20 times I think it is been predicted the actual values. Okay, so this is the complete web application. Now let's just check it out for one of the Indian stock symbol. Okay, check for HDFC Bank. HDFC Bank. The stock symbol for this one is HDFC Bank.ns. Let me copy it here to app, press enter. It's getting the data. Okay, if you see here, it is changed to rupees. Okay, stock data, price versus moving average of 50 days, and price versus moving average of 50 days versus 100 days, and price versus moving average 100 versus moving average 200, and original price versus predicted price. So this is our end-to-end web application which will predict the stock price for the future days. Thank you all. Thanks for watching this video. If you like this video, please do subscribe to our channel, and please do like the video and share it with your friends, and do comment if you need any help or if you need any suggestions.